Hey everybody, Mr. Barry here. We're dealing with standard form of a quadratic function. So we've been in this second unit for the class talking about different types of forms on quadratics. Went through intercept form, vertex form. Now we're talking about standard form, and we're going to go ahead and try to practice graphing a couple of them. We'll note here a couple different things, which is we want to make sure that we're spending some time working on these in terms that this is probably going to be the one that involves the most work because it's already kind of cleared up there on the standard form. Want to just make sure we're aware that we understand that our general form here is y is equal to ax squared plus bx plus c. So our a value is the coefficient for whatever variable squared we have. The b value is the coefficient for whatever variable we have just by itself, and then the c is the constant here. For standard form, still got to find 5 points just like the other two that we're talking about. We'd like to have 5 points on our graph at the very least. The very first thing that I want to do here in order to solve that is just kind of rewrite out my a, b, and c. This is going to help me as we go, not only in this unit, but the following unit afterwards. And in this function right here, my a value is 2, my b value is 6, and my c value is 3. From that, we know from the previous videos that in standard form it is easiest for us to find the y-intercept. So the first point I want to check out here is our y-intercept. We know that the y-intercept has an x value of 0, and if we were to take an x value of 0, plug it in up here, it's going to be what we have for our c, what we have for our constant. So in this problem, the y-intercept is 0, 3. 3 because that's the c value, that's our constant in this problem. So when it comes to doing this problem, y-intercept is incredibly easy to figure out. I'm going to go ahead and draw the dot right here for that. Before I even find the vertex or the axis symmetry, before that even, I'm going to go ahead and figure out the y-intercept. After that, I want to go ahead, just like I did in the other couple, and spend some time talking about, can I find the axis symmetry in the vertex? We know that we have a specific formula, especially in standard form, in order to find the axis symmetry. So second, we're going to go ahead and figure out the axis of symmetry. And in order to do that, I'm going to use the formula x is equal to negative b divided by 2a. b divided by 2a. That doesn't change. That is a formula we're going to be able to use throughout. Got to be aware of that negative symbol. Just let it alone. Be careful with it. When we plug things in, like our b value here is 6, and our a value is 2, I want to leave them separate of that negative symbol out in the front. So I have 6 over what ends up being 2 times 2. 2 times 2 is 4. And it's okay for us to go ahead and calculate this out. If it's a decimal value, that will be all right. In this case right here, we have x is negative 1.5. X is negative 1.5. So from that, we just calculated the axis symmetry. It would not hurt us here at all to go ahead and put our dotted line that runs vertically, the mirror for our parabola here, at x is negative 1.5. There's 1, there's 2, somewhere in between. We'll try our best to do it right there. So it might be worth noting here that if our axis of symmetry is negative 1.5, we don't know what the y value is quite yet. We don't know what the full vertex is, but I know my x value, the axis of symmetry, would be negative 1.5. It would be okay for me to use that axis of symmetry to mirror the y-intercept that we already found. So we have 0.3, 0, the x value here for our y-intercept is 1.5 spots away from the axis of symmetry. On the other side, 1.5 spots away would be -3, and we know that these two have to have the same y value if we're mirroring it across the axis of symmetry. So I'm going to go to negative 3, 3, and I have my second point right there. We'll go ahead and calculate the rest of the vertex. We already know the x value. The axis of symmetry here is negative 1.5. I'll take that negative 1.5 and plug it into the original function. Might be a good idea to break out a calculator if you don't have one already out with you. Negative 1.5 squared plus 6 times, might have to rewrite this, 2 times negative 1.5 squared plus 6 times negative 1.5 plus 3. And I myself have to go grab a calculator, and I'm going to try my best to type that all in on one shot. Might as well give it a go. And as I'm doing that, of course, if you wanted to go right ahead and show your work, you're more than welcome to. But for me, I'm going to type it all in, and oddly enough, I get that y is equal to negative 1.5. Go figure, right? So for our vertex here, I have a negative 1.5 for the x. Technically, I have a y value of negative 1.5 also. So I'll graph that point. It'll be a little bit thought-provoking here. We already have our axis symmetry. I go down 1, and halfway right there would be our vertex. I have 2 more points to figure out. If I pick one x value and plug it in, I can always use the mirror to get the last point. Doesn't matter which one you really pick. What I would suggest to you again is that our numbers kind of make sense in the process here. We're relatively close to the axis of symmetry. So for me, and in this problem right here, I'm just going to go ahead and pick the number negative 1 for this. So I'll pick negative 1 to plug in. It should be relatively close to the other ones we already did. Negative 1 squared would be 1, times 2 is 2, negative 6 plus 3, and we would get a y value of negative 1. So the x value there was negative 1, the y value there was negative 1. Negative 1 is a half of a spot away from the axis of symmetry, so we should have a mirror on the other side there. Let me go ahead and put negative 1 in. There it is right there. So on the flip-flop of that, another half away from the axis of symmetry would be the spot negative 2, comma negative 1. So I have my 5 points there. I'll go ahead and connect the dots. Try my best to make this look good. Have my parabola. So again, the process here was to go ahead and start off by using the y-intercept, find that axis of symmetry, and mirror the y-intercept if possible. Finish off the vertex by plugging in the axis of symmetry and then getting a 4th and a 5th point using the mirror.